Science isn't about opinions, beliefs, or what sounds right. It's about identifying lawful relations that hold whether you like them or not. Behavior analysis lives or dies by the standard. The purpose of science is to achieve a thorough understanding of the phenomena under study. In applied behavior analysis, that focuses on socially important behavior change. Science differs from other ways of knowing because it relies on systemic observation, experimentation, and logical analysis, not intuition, authority, or tradition. Scientific knowledge exists independent of the scientist, and its value does not depend on who prefers it or who benefits from it. Science is often misunderstood or misused, but it is not a tool for validating beliefs or deciding what should be true. Its function is to discover facts and lawful relations that operate regardless of personal opinion. Scientific investigation builds knowledge by contributing to three levels of understanding: description, prediction, and control. Each level plays a distinct role, and none of them can be skipped. Description is the first level of scientific understanding. Systematic observation enhances understanding by allowing scientists to describe events accurately. At this level, behavior and environmental events are qualified, classified, and examined for possible relations. Descriptive knowledge consists of carefully collected facts, and it provides the foundation for every other scientific activity. Without description, there is nothing to analyze. History shows the power of description. John James Audubon's extensive observation and documentation of wildlife produced detailed records that advance scientific understanding without manipulating variables. In applied behavior analysis, descriptive research has included systematic observation of classroom behavior, such as tracking rates of teacher praise and reprimands across grade levels. These descriptive findings did not explain behavior, but they revealed patterns worth investigating. The second level of scientific understanding, prediction, attempts to answer them. Prediction occurs when repeated observations show that two events consistently covary. When one event reliably occurs in the presence of another, scientists can predict the likelihood of one given the other. This is correlation. It is useful, but it is limited. Science is designed to prevent two things from happening together, does not mean one caused the other. Control is the line you have to cross. Prediction allows hypotheses about relationships, but it does not demonstrate causation. Correlation findings can suggest possible causal variables. They cannot confirm them. For example, certain weather conditions may correlate with increased drowning incidents, but correlation alone cannot identify what actually produces the outcome. Prediction improves confidence, but it does not establish responsibility. In applied behavior analysis, correlational studies often examine relations between problem behavior and environmental events such as attention escape or access to materials. These findings can guide further investigation, but they must be interpreted carefully. Prediction tells you what tends to happen. It does not tell you why it happens. The third and highest level of scientific understanding is control. Control is achieved through experimental demonstration. At this level, scientists manipulate one variable, the independent variable, and observe changes in another, the dependent variable. That change must be attributable only to the manipulation. This is not optional. This is the standard. Control establishes functional relations. A functional relation exists when a specific change in one event reliably produces a change in another. Experimental designs allow scientists to test whether what was predicted actually occurs under controlled conditions. This is where science earns its authority. Control is the foundation of applied science. The technologies that shape everyday life, medicine, engineering, and applied behavior analysis are built on experimentally demonstrated functional relations. In behavior analysis, control allows practitioners to identify variables that reliably influence behavior and design interventions that work because they are based on demonstrated causation, not assumption. Importantly, just because one event precedes another does not mean it causes it. Experimental control is required to demonstrate causation. Functional relations are established only when behavior changes as a direct result of manipulating environmental variables, with other explanation ruled out. Scientific knowledge progresses in order. Description organizes what happens. Prediction identifies consistent patterns. Control confirms causation through experimentation. Each level builds on the previous one, and each contributes to a complete scientific understanding. Without description, there's nothing to analyze. Without prediction, there's nothing to test. Without control, there is no science, only observation.